So hello everyone, today we are going to solve the problem maximum number of operation to move one to the end. So first of all, let us see the problem statement. So the problem statement is saying that you are given a binary string s and you can perform the following operation on a string any number of times. Okay, so what other operation we have to perform? Like we can choose any index I from the string. Okay, from index 0 to its length minus 1, such that s of I is equals to 1 and s of I plus 1 equals to 0. Okay, so we have to choose such index such that that current index is 1 and the next index is 0, and move the character si to the right until it reaches the end of the string or another one. Okay, so for example, this is the given string 0 1 0 0 1 0. If we choose the character at the first index, so like if we choose this index, so here it is 1 and the next index is 0, so yeah, we can choose this index. And now what the operation we have to do, we have to move this character to the like the end of the string or the nearest before 1, so we can move it here. So what the next string will become, it will become like this. Okay, so let us take one example from our side. So let us say we have given one string 0 0 1 1 0 0 1 0 1. Okay, so in this like what can we do, we can choose many indexes, such as this index here, it is 1 0. We can choose this index. So first of all, let us say we will choose this index. Okay, so let us first choose the 0th index, because here it is a 1 and the next index is 0, so we can choose it, and now we can move it until we get 1. So like this one will come right before the next one. So what the string will become, it will become like 1 0 0, then 1 1 1 0 0 0 1. Okay, so this is basically the one operation. And yeah, in and next and other operation, what we can choose, like we can choose this index 0 1 2 3 4. We can choose the fourth index, because the fourth index is 1 and the fifth index is 0. So yeah, this is a valid possible combination we can choose. So what will the string become after moving this 1 to the to the end of the string, or the nearest or before the nearest one? So it will become like 0 0 0 1 1. So like this is the string we will get after moving the 1 to the end. And now in the next operation, we can choose this one and move it into the end. So 1, it will become 0 0 0 1 1 1. So currently we have performed 3 operation in that. Now first of all, let us see that what we have to return. So here we have to return the maximum number of operation we can perform. Okay, so think like, how can we achieve the maximum number of operation? The maximum number of operation can be only achieved if we move all the 1 to the end of the string. Okay, so like here in this case only we can like do maximum number of operation. Okay, so like if we like move all the present one to the end of the string, and all the zeros to the left one, all the zeros to the right one, so in this case only we can like we will be performing the maximum number of operation. Okay, so uh, like in this case you can see, like we have moved the 3 1 to the end. Now one is left, so like move this one also to the end. So like the string will become 2 3 4. So like string will become like this. Now after like this case, we cannot move any of the 1 to the end. So like this is the maximum we can achieve. So in this case, like by moving all the 1 to the end, we can achieve the maximum number of operation. So what will be our agenda for this question? So the main agenda of this question is to move all the 1 to the left extreme right of the string. Okay, so like how we'll be doing it? So let us see our implementation for this question. So first of all, we will try to move from the end of the string. Okay, we will try to move from the end of the string and check that how many like chunks of zeros we get. Like for this question, if we for this one, like there is no zero, so this cannot be moved. And like for this one, like how many chunks of zeros are there? There is only one chunks of zero, which is this one. So like we can perform only one operation on this one. Okay, we can perform only one operation on this one. So we will perform one operation on this one. On next one, like how many operation we can perform? It will be basically the number of chunks of zeros we will having after this one. So here we are having only one chunks of zeros. Okay, So on this index as well we can perform only one operation, and on this one, like how many operation we can perform? We can perform two operation. Why? Because we have two chunks of zeros, like the first chunks of zeros is this and the next chunks of zeros in this. So in the first operation we can move the one to the next of these zeros, so the one will come right next to these zeros, and the next operation we can move this one to the next chunks of zeros. So here we can so for this one, like we will apply two operations. Okay, so like let's see the implementation. Like we will be starting from the last from the last index itself, and we will count like how many chunks of zeros we have get till now. So for getting the chunks of zeros, we will take one variable count which will store the chunks of zeros, and in the next variable answer we will store like the maximum number of operation we have performed until now. So let us take one variable I for the like index which will be on the last index, and we will run this operation until we reach the first index. Okay, so like what are the cases here? Like if we get any one in the string, okay, if we get any one in the string, so we will like add the count in the answer. Like we will add the number of chunks of zeros to our answer. Okay, so here the answer like count will be added to the answer, and we will reduce the j, and like we will continue, we will just skip the below part and come to the next one. Okay, like come to the next index. But let's say like if we get 0, okay, in the next case if we get any 0, so like we will move until we get the next one, because we want the chunks of zeros. So for this we will run a while loop. While s of I is equals to 1, s of I equals to 0, we will continuously move it to the left. Okay, so we will continuously move on to the left, and let us not j here, it will be I here, and while I greater than equals to 0 we have to put this condition as well. So we will move until we get 0, because like for anyone we have to move to the right of that 0. So like number of zeros won't be matter here. Here we matter like the chunks, like how many chunks of zeros we get. So here the one chunks is passed, so now we will be on the index which is 1. So like we will increase the counter means like we get one chunks here, and then here we have to also put I here. Okay, so like we get the counter, we increase the counter. So let us dry run for this test case. So first let us dry run for the given this test case. So let us write it here. Okay, so what will happen for this test case? Like I will be currently at the last one. So if s of I equals to 1, so yeah, s of I is 1, so like counter is currently 0. So in this case like the answer will be still be 0. Answer will be still to 0, and counter is also 0 here. For the next I, the I will be 0. Okay, so like I will go to here, and this loop continue will come into action, and this won't be executed. So I will now come to the second last index, and now it is 0. So this else will be executed, and while I greater than 0, so if s of I1, we will move until we get the 1. So like the next index I will come on to this, and the loop will break, and we will increase our count to 1, and then again we get 1 on this index, and we will increase the answer by counter. Like we got one chunks of 0, so we will increase our answer by 1. So like in the next loop the answer becomes 1, and counter also becomes 1, and then again I will reduce to here this index, and again we got 1, then answer will now become 2, and still counter is 1. Now we again come to this zeros, so this will continuously pass, and we will come on to this 0. So now answer count become 2 here. Okay, like count become 2 here, so count become 2 here, and answer will become 4 here. So like this is the dry run of our test case. Now let us return the answer and check that if we are getting all the test cases passed or not. Okay, so yeah, test cases are the sample test cases has been passed. Let us submit and check whether it has passed all the test cases or not. So yeah, like all the test cases have been passed. So thank you everyone, thank you for watching this video.